Yeah.
Okay, let's see. I'm gonna share my screen. So we'll start with the question paper. Basically, we'll do all the exercises in terms of doing the SQL commands and drawing these diagrams and all of creating these tables. All of this we'll do it tomorrow, because then that'll be fresh in our head. We have already done all of this, but we'll do a recap again. Okay, so we'll just go with the theory and we'll finish off with all the questions that we have here. Okay, just 1 second. Yeah, my sister is sending that you are not live yet. I think there's a delay there. It's fine. Okay, so let's start with the first question. Explain the term transaction in the context of database management system with the help of an example. What are the problems associated with the concurrent transaction when they're executed, and explain one of these problems with the help of an example. So I'll try to recall what I remember, and then we'll take a look at the answer. So I think transactions are basic unit of work in a database system, and they are used to perform different requests, such as sending a query request, creating a table, also deleting, altering, all of those things. Now, in the real world example, transaction would be like one person going to the bank, and then he goes ahead and withdraws an amount. So the withdrawal amount could be an example of transaction. And then if we have to write a pseudo code for this, we basically write that, let's say there's a person who wants to withdraw an amount of, and he has an account called X, and we write that transaction withdrawal, and we put the withdrawal amount in the bracket, and then inside of that we put a condition that if the account exists, then we check if the balance is greater than uh, the amount that is trying to withdraw, then go ahead and subtract the amount from the balance and write it and then commit it. And then otherwise, if the balance is not enough, then print a message saying that the transaction got failed. And otherwise, if the account doesn't exist, then just send a message the account doesn't exist, and then we end the transaction. So that's your transaction. Problems associated with the concurrent transaction. So first we need to understand what this concurrent transaction is. So concurrent transaction means that a transaction, when multiple transactions in a database happen simultaneously, concurrently. So that's what the concurrent transaction is. And the problems associated with could be multiple. For example, that while one transaction is trying to update, um, one transaction goes and reads the record, and then second transaction goes ahead and reads the same record, and the second one makes an update on that while the first one is still in the process. So there could be some misrepresentation of the data. The actual data may not be visible. So that's one of the issues, and there are different types of problems associated with this, which we will see in a moment. So let's see. Actions. Okay. So a transaction is a basic unit of work on a database management system. It defines the data processing on the database. For example, some of the transaction at a bank may be withdrawal or deposit of money, transfer of money from A's account to B's account, etc. A transaction would involve manipulation of one or more data values in a database. Thus, it may require reading and writing of the database value. For example, withdrawal transaction can be written as a pseudo code. Assume that we are doing a transaction for a person whose account number is X. We put transaction withdrawal, pass withdrawal amount into it. We begin transaction. If X exists, then read X dot balance. And if x dot balance is greater than the withdrawal amount, then subtract withdrawal amount, write x dot balance, commit, else display transactions cannot be processed, else display account x does not exist, and then we end the transaction. Again, recap on the concurrent transactions. In a multi-user system, multiple users can access the same database at the same time, which is known as concurrent transaction in database. It means same database is executed simultaneously on a multi-user system by different users. Dbms must ensure that two or more transactions do not get into each other's way. That is, the transaction of one user should not affect the transaction of the other, and even the transaction issued by the same user should not get into the way of its own. What are the problems? The problem occurs when two different database transactions perform the read or write operation on the same database item in an interleaved manner. That makes the values of the items incorrect, hence making the database inconsistent. These problems are lost update. So in lost update, suppose two transactions T3 and T4 are concurrently running. So T3 goes and reads, so actual value of the X is 10,000 at the beginning. T3 comes and reads the value, gets the value as 10,000. Then T4 transaction comes and reads the value of X, gets it as 10,000. Then T3 subtracts this amount. So the remaining balance is 10,000 minus 5,000, which is 5,000. At this point, T4 goes and adds 3,000, but because it read the value of X is 10,000, if you subtract 10,000 minus plus 3,000, actually add, not subtract. Yeah, 10,000 plus 3,000, it becomes 13,000. Ideally, it should have been 5,000 plus 3,000, but because the other transaction is happening at the same time simultaneously, and it had just read that the amount was this much. So for this transaction, it's adding that amount, which is not correct. That is why it's not good to have multiple transactions at the same time. So there's a mismatch in the data. So at this point, T3 writes X, so X becomes 5,000, and T4 writes X, so X becomes 13,000. So X should have been 8,000, but it's actually 13,000. That's a problem. It's a lost update problem. So after the execution of both transactions, the value is X, while semantically correct value should have been 8,000. The problem occurred as the update made by T3 has been overridden by T4. The root cause of the problem was the fact that both the transaction had read the value of X as 10,000. Thus, one of the two updates had been lost. So this is a lost update. And we can say that the lost update has occurred. Another problem is unrepeatable reads. So in the question paper, it's asked you to give all the types of problems with the concurrent transaction, but wants you to give example of only one. So you can give example of one and just explain the others. So unrepeatable reads. Suppose T7 reads X, and once it's read X, another transaction T8 updates the value of X to 3,000. It again reads X for some reason, but this time it gets the value as 3,000. So again, there is a inconsistency. So if one of the transaction reads the value of the same data twice while it's being updated by another transaction, then there is a inconsistency that occurs. So if between two read operations, another transaction modifies the value of the same data, that's unrepeatable reads. So there's a problem here. Dirty reads. Dirty read problem occurs when one transaction updates an item of the database and somehow the transaction fails. And before the data gets rolled back, another one updates the data. So look here. Okay, thanks, Maya, for adding this. Okay, so T9 updates the value of X. So initially the value of X was 200. T9 updates the value as 500. And then at the same time, T10 comes and reads the value of X. It gets it at 500. Now, the update that was done by T9 doesn't go through, it fails. So because it failed, we can't keep this value in the database. So it has to roll back to the original value, which is 200. So it rolled back to 200. But there was a read done by another transaction at that point. So and it got it as 500, and now imagine it is performing operation on that. So it's actually got incorrect value because this never got updated because there was an error and it got rolled back. So this is not actually the correct value because it's never went in the system as saved. So this dirty reads, reading it incorrectly. So when one transaction updates an item and somehow transaction fails, updated database item is accessed by another transaction at the same time. So there's a conflict that happens. That's dirty read. Then you have inconsistent analysis. This problem occurs when more than one data items are being used for analysis. Sumaya, can you explain this example?
Yes. So T1 is reading A, B, and C and adding them up into sum.
Mm-hmm.
So when it's read A and B, after that A and B have been modified by T2. You can
Mm-hmm.
see they're modifying the value. And then
Yeah.
T2 modifies C, and T1 reads C after it has been modified. So two of the values were read before they were modified, and C was read after it was modified. So it's the sum is inconsistent.
Hmm. Okay. Okay. No problem. But anyways, we have to only explain one of the examples, so it's fine. I mean, we can just say problem occurs when more than one items are being used for analysis, while other transactions modified some of those values. That's inconsistent analysis. Just a recap, quick recap um, for that question answer. So transaction is a basic unit of work on a database management system. It defines the data processing on the database. Then you can give the example of the bank withdrawal in your own way. This is not like a code, it's just like a pseudo code. So just explaining how what a transaction would be like. Now, concurrent transaction are like in a multi-user system, multiple users can access the database at the same time. That is called concurrent transaction. Then what are the problems? A problem occurs when two transactions are working on the same data and they're trying to update that in an interleaved manner. Okay, so that's when the problem occurs. So what are the problems that occurs? One is your lost updates. So lost update occurs when both the transactions read the value of x and one of the two updates has been lost because it's been overridden by one of them. That's when the lost update occurs. So one reads, second reads, the first one makes a change, second one makes a change, but because it read the previous value, the value that was written by is incorrect, so it's overridden. So both transaction has read the value, one of the two updates have been lost. So when the update has been lost, that is when it's called lost updates. Then you have unrepeatable reads. If between two read operations, another transaction modifies the value of the same data, that's when the unrepeatable reads happens. That one transaction is reading it twice, but in between that, another transaction updates the value. So that's unrepeatable reads. So that's inconsistency in the data. Dirty reads, one transaction updates the value, but it didn't go through. And while it was rolling it back, while it was putting it back to what it was originally, somebody else came and read it. And of course, it would get the value that was updated, but actually did not get updated. So again, an inconsistency, there's a conflict. That's a dirty read. And an inconsistent analysis is when more than one data items are being used for analysis, while other transaction has modified some of those values. That's when inconsistent analysis happens. So that answers your this question. What is transaction? Give example. So you'll give example of the bank. It tells you about what are problems associated with concurrent transactions. In one line, you can explain what is concurrent transaction and then give those types, which is lost updates, inconsistent analysis, a dirty read, and unrepeatable read, and just give example of at least one of them because it's saying give me one example at least. Then we go to the relational model. So that's your 10 marks question. Then we go to relational model of the database management system. So a relational model of database management system is basically based on the relational model, and it was designed by EF Cod, and that was yeah. And there are different examples of the relational database management system. So there is MySQL, there is MS SQL, then you have Microsoft, Oracle DB2. So these are the examples. Uh, and this is basically containing a table which contains rows and columns, and the data, it contains the related data in form of rows and columns. And inside of this you have you can explain more detail if you want to, like you have the attributes, you have rows, you have columns, and then you can give a little bit more information on that. It talks about differentiate between a relational database management system and object oriented management system. So a relational database management system is based on entity. So an entity is used which contains the related rows and columns, and an object oriented programming object is used. Uh, and apart from that, the goal of the relational database management system is that it offers the data independence in the database system. However, object oriented programming goes ahead and focuses on the data encapsulation. In relational database management system, we use the primary key to identify the unique values, and in object oriented programming we use the object ID. And let's go further and let's look at the actual answer. um, Relational model. Okay. Relational Database Management System, RDBMS, are based on the relational model introduced by EF Cod, example SQL, MS SQL Server, IBM, DB2, Oracle, MySQL, Microsoft Access. These are examples. Uses tables to store data. Each table is called relation, which is a collection of related data entries and contains rows and columns. Each table represents some real world objects, such as person, place, or event about which information is collected. Difference between these, so data is stored as entities defined in a tabular format. Here, data is stored as objects. In Rdbms, it handles simple data, or Dbms handles large and complex data. Here, an entity refers to a collection of similar items having same definition. Here, a class refers to the group of objects having common relationships, behaviors, and properties. In Rdbms handles only data, or Dbms handles both data functions operating on that data. Rdbms keeps the data independent from application program, or Dbms implement data encapsulation. Rdbms, a primary key identifies an object in a table uniquely. Here, OID represents an object uniquely in a group of objects. Okay, let's move on to the next question. Let's see, D and then E. Oh, I'll let Sumaya do this. Define first normal form in the context of relational database management system. So Sumaya, I don't think we even have to look at the slides. You can just say it.
The first normal form is a table is in the first normal form if it has atomic values. That means it shouldn't have multi-valued or composite attributes. And each row of the table should be unique.
Mhm.
And
Yeah, I guess that's it, right?
there was one more thing.
Okay.
Yeah, each attribute should have values of the same data type.
Okay. Okay. So each row which is tuple should be unique. Uh, the attributes should be of um, atomic value, and the data type should be same, which means the domain should be the same, I believe, for them, each one of them, in their same attribute. So let's take a look of an example. For how do I search it? First normal form, like that. A relation is in one NF if each of its attribute has an atomic value. In other words, if it meets the following condition, there are no duplicate tuples in the relation. Each data value stored in relation is single valued, which is the same as the atomic value. And entries in column are of same kind, same type. Example is this. Here we have a relation, and we have employee ID, employee name, employee address, employee mobile. This does not, this is not in first normal form, is because employee mobile is not atomic value, it's multi-valued. There are multiple values here. So that is why it is not in the first normal form. To convert it, we're going to normalize it. So what we're going to do is we'll put this whole thing twice, and each time we are going to put only one value. So that way, this guy will be repeated, but in each of them, it'll satisfy the condition. So like you can see here, the John 102, this has been put twice, and then we put this record twice here. Okay, and the same thing goes for this Lester also over here. So to make the table comply with the one enough, we need to create separate rows for each mobile in such a way that none of the attributes contain multiple values. Moving on, सुमेय आपको 2 नंबर मिल जाता है. अब जाते हैं list. Explain. Sorry.
Just a quick question. So,
Yeah.
so for the first normal form, we have like three different conditions, right? It should not have like composite value, and
Yes.
the same record should not be like duplicated twice. So,
Correct.
in the exam, do you just explain like one of them, or do you make tables for each of
No,
them?
no, you don't have to make tables for all of them. Uh, First, just explain all 3 points, okay,
Yeah.
and then give example and say that why this table is not. So a table does not have to not meet all of the requirement to be in a first normal form. Even if it meets, does not meet even one requirement, like in this case,
Mm-hmm.
atomic,
Yes.
non-atomic. This is not non-atomic. So that's when it does not meet. It may not meet one. It may not meet two of conditions. It may not meet all three of them. Even if it's single is not there, it's not in first normal form. So just explain one of them. Like this example is fine.
Right. Okay.
And I would say in exam, don't experiment. Just whatever is you prepared, just use that, because in exam we don't have that much of time actually.
Yeah, and it's anyway just a 2 mark question. So
Yeah, and
yes. Okay.
anyways we like we have so much to write unless your handwriting is really fast. Okay, so we now talk about the 6 advantages of database management system. I don't really recall it, but I'll try to get it out of on the top of my head to see what's there. Let's say if I was to sit in the examination today without any revision, what can I get it out of that? So advantages of data management system: it allows us to create and manage data, um, and then I would say I'll compare it with the file system probably. So in file system you have duplication of data. So here in database management system we take care of the redundancy by going ahead and using normalization to make sure the data is unique. So there's no duplication there. There is ease of access. I know that Kritika told some story. I don't remember that story where you get the data in your hand and then you don't know what to do with it. What was that story, Kritika?
Yes. Okay. So it's about Kritika. Kritika goes and she accesses data. So the first point is ease of accessing data.
Mm-hmm.
This is according to your PPT, okay? The
Okay.
first, Kritika goes and tries to access data. So the first point is ease of accessing data. Now she has a lot of data.
Mm-hmm.
She has to store it properly.
Mm-hmm.
So the second point is storage and management.
Okay.
So data can be directly stored in the form of objects, all of that.
Easy,
Uh,
easy to query. Yeah. Okay. Cool.
Yes, and then now that she has a lot of data, this data may not be like good enough. So the third point is avoiding data redundancy. So
Mm-hmm.
like the data should not have any redundancies. That is the third point. And then the fourth point is so now that the data is normalized and the data is good, other people also want that data. So
Yeah.
concurrent data. and
Yeah.
and now that other people have come,
Mm.
तो मतलब सब लोग आ ही गए हैं, तो like integrity होनी चाहिए, like it's a community that we are in. So
Okay.
our community has values, and that, which is
Ethics.
database integrity, yes, ethics.
Correct. Correct. Absolutely. Awesome story. So you have the data. What to do with it? You're supposed to store it. Store in form of an object. And then if you're storing it, there shouldn't be any redundancy. So we do normalization and make sure the data is unique, and then let others have that data. So simultaneously multiple users can access that data. And now since the whole community is built, we want to make sure that some serious business, no monkey business is going on. So we have to really be strict and make sure its integrity is followed. So we bring our monitor called constraint, and we put the constraint on it and make sure that it is uh, secure. And what was that? There was one word for that. One second, I'm forgetting. Advantages. Accurate. Yes, accurate. Accurate and consistent. Integrity means accuracy and consistency. So yeah, good. I think I'll be able to write it. Okay, so in file system, different files are created for each user, which they can access. Dbms removes the redundancy by granting access to the users and decides which and how many parts of the data is accessible to them in the database. Storage and management, data can be directly stored in form of objects, unlike file system, making it easy to query. Avoiding duplicates and redundancy. In file system, storage of data might happen multiple times. Data normalization is used in DBMS to avoid duplicate data. Concurrent data accessing, users can access data simultaneously through different applications. So this is what we spoke about in the earlier questions, where it asked that what is not what is, but what are the problems of the concurrent uh, you know data accessing. So this is what it talks about here. Integrity means data should be accurate and consistent, and this is implemented by enforcing checks or constraints of the data while it is being entered and manipulated in the database. Data of a database is not allowed to violate this constraint or rules. For example, a constraint on age of an employee can be between 18 and 70 years only. While entering or modifying the data of an age of an employee, the DBMS should enforce this constraint. Moving on to the next question. So asking for six advantage. One, two, three, four, five. So I have five, but I'll probably break it into. Okay, let's see if we have one more. Okay, so creates and manages data. Programmers can easily retrieve, create, update. So we talk about programmers basically making the sixth advantage. Yeah,
We can also talk about security, like mm, data security.
yeah, of course, 100%.
Yes.
कम नहीं पढ़ना चाहिए, ज़्यादा हो जाए. Programmers can easily retrieve, create, update, and manage data. Okay. Users can also create their personalized database as per requirement. थोड़ा generic भी डाल सकते हैं यहाँ पे. Cool. I think we're sorted for this 6 mark question if it comes. और नहीं आया ना ये सब तो I know what I'm gonna do. Because last time हमने इतना प्रिपेयर किया था और ये बेवकूफ लोगों ने पता नहीं क्या किया. Anyways,
और इस बार तो बस एक क्वेश्चन पेपर है, सबसे बड़ी प्रॉब्लम वो है। पिछली बार तो फिर भी 10 था, तो मतलब ओके, कुछ तो
हाँ,
आइडिया था।
नहीं तो सी आई थिंक DBMS आई एम लिटिल वरीड व्हाई बिकॉज जो असाइनमेंट है ना जावा में तो बहुत से क्वेश्चंस हैं असाइनमेंट के अंदर, तो like we prepared a lot but here we don't have much, just one question paper like you said, but it's okay I think जो मेजर टॉपिक्स हैं वो ऑलरेडी हमने कवर किए हैं, तो आई एम प्रेटी श्योर कि इसमें से आएगा, लेट्स सी. So moving on, what is the use of indexing in RDBMS if two indexes were created in a database, on one on primary index and other on secondary index? Which of those two indexes will be of more advantage? Justify your answer with the help of an example. So you have to go to indexing. Let's see if I can remember some of the information. So indexing basically reducing the disk access and improving performance by creating index. Okay, so that's indexing. What was the other question? Okay, this was the question. Okay, index talks about primary index and secondary index. This example is the most difficult one to give. So much of calculation going on there. Anyways, so indexing is used to optimize performance of a database by minimizing the number of disk access required when a query is processed. For example, a book has a table of content to find them easily. Index is a type of data structure. It is used to locate and access the data in a database quickly. Indexes can be created using some database columns. The first column of the database is a search key that contains a copy of the primary key or candidate key of the table. The values of the primary key are stored in the sorted order so that the corresponding data can be accessed easily. Okay, so indexing is used to optimize performance. And how do we do that? We do that by minimizing the number of disk access. So generally, if you are accessing the whole database, is going to take long time compared to if you just accessing the index. So take an example of a book. uh, if you want to read a particular chapter of the book that you probably would have read before in the past, and you want to get to that chapter, imagine you don't have the index. You have to go search the entire book, like keep turning the pages and look for that particular chapter. But if you have the index, you can just read the title, get the page number, and directly go there. So that's exactly what the index is, just like your book has table of contents. So it's type of data structure, making it easy to locate and access the database quickly. Two things when the index is created. First is search key, which could be primary index or primary key or candidate key. And then you have this second column as data reference. So this will contain the data reference, contains set of pointers holding the address of the disk block where the value of the particular key can be found. So that's your indexing. Okay, so I'd like to ask somebody. So in the examination, we won't have the slides. We'll have this question paper. We'll have to look at this question paper and then recall what we remember. So Sumaya, can you recall what is indexing in RDBMS? Looking at the question paper.
Index is used in Rdbms to reduce access time of records.
Okay. So give me a couple more points. So for example, how is the index created? What all is there in the index? What type of columns are there in the index?
Index has a search key column and another column that contains the address to the records.
Yes. Yes. Correct. Okay. So index is the data type data structure, and it is used to reduce the number of disk accesses in the database. Kritika, can you give me 1 point? You can repeat the point also. 1 point about what is indexing in RDBMS.
There is a search key and there's a data reference.
Mm-hmm.
The search key is basically the key from which you can identify where the data will be. And
Yeah.
yeah, so there's primary and secondary data.
Yep.
um, yes.
Primary, it can use primary key or candidate key, and then the second column is your place where the address, the
The set
pointer,
of
the
data.
address to that particular block is stored.
Yes. Yes.
And it reduces the number of disk accesses by improving the performance with the help of this by creating this index table. Okay, now the difficult one. That's it. Example. We'll look at since we are here, we'll look at the primary index and secondary index also quickly before we go on the example. So in primary indexing, index is created on the basis of primary key of the table. We store the primary index of a block and the block pointer addressing pointing to that block. The primary keys are unique to each record and contain one-to-one relationship between the records. As primary keys are stored in sorted order, the performance of the searching operation is quite efficient. The primary index can be classified into two types, dense and sparse. So this is your primary index. Uh, the first column contains the primary key, which is the key to the first record in the block. So one block contains multiple records, so it's going to use that key, the first one, and in the second one will be the pointer to that block, so it'll contain the pointer address to that block. Okay, and because they are in sorted order, it's easy for us to access it and it's faster. Two types of indexing, dense and sparse. In dense index, each of the primary index record is um, matching to the to each record in the into the database, so there's one to one. Okay, in sparse index there's a gap between different records. So in this case, for example, this is pointing to a block, then another one is pointing to the block. So let me give you example here. So dense index contains an index record for every search key value. So every search key value, there is a index for that. Okay, so number of records in the index table is same as the number of records in the main table. Needs more space to store index record itself. Index records have search key and a pointer to the actual record of the disk. In the in the sparse index, index record appears only for few items. Unlike dense index, where each item points to a data record in the main table, in sparse index, each item points to a block in a gap. Okay, so you'll point to the block in a gap. Okay, column group together. Just for your knowledge, I'm not going to go through this, but clustering index means that two or more columns are grouped together. Okay, secondary index is a file that contains records containing secondary index field value, which is not ordering field of the data file. Okay, so for example, name is not in the order. That's why you're calling it not ordering field of the data file. So basically, this is secondary index, which is basically a file stored in a hard disk, and it contains a secondary index field value, in this case, name, and it was not in ordered structure, and then the pointer to the block that contains the record. So like in this case, the first one, it belongs to this block, which contains the record. So secondary index is a file that contains the secondary index field value, which is this, and then the pointer to the block. Consider a situation when database is to be searched in alphabetical order of the student names. Any search on the student name would require sequential data file search, as there is no ordering on the student name. Thus, searching on the student name is going to be very time consuming. Thus, you need secondary indexes in the database system. In this figure, names in the data file are unique, thus are being used as an alternate key, and each name is therefore appearing in the secondary index. And here pointers are block pointers, thus pointing to the beginning of the block and not the actual records. It's pointing to the beginning of the block. Key thing to remember in the primary and secondary index is that here the first here you have a file, and plus the index field value is generally picked up from the one which is not in ordered list. It could or it could not be. It is not 100% sure. It's not guaranteed that it will be ordered. But in the primary key, it will always be ordered. So generally, it chooses the candidate key or the primary key for that. For example, if it was primary index, they would have chosen the enrollment number. Now, this is the example. So, Maya, would you be able to explain this?
Yes.
Okay.
If two indexes were created in a database, one on primary key and other on secondary key, which of these two indexes will be of more advantage? Justify with example. The secondary index improves the search time to a greater proportion than that of primary index. This is due to the reason if primary index does not exist, even then you can perform binary search on the blocks of data records as the records are ordered in the sequence of primary index value. However, if a secondary index does not exist, then you may need to search the records sequentially if the records are not ordered by the secondary index value. So if we take the example of a book, then you can think of the primary index as the table of contents. So all the chapters are in order. So even if you don't have the table of contents and you know the chapter number, you can find the chapter using binary search.
Yeah.
But if you're searching by keywords, you will need the index at the back of the book. So that's like the secondary index.
Okay.
If you don't have that index, then you'll have to search the whole book starting from the beginning sequentially for your keyword.
Can you explain this example once again?
The one of the book or this one?
Yeah. The book. I don't think I'll write this in the exam. I can't. It's just so hard.
Same. I was going to say the same thing. Do you have another example?
You see, it's saying give example. It's not saying give this example. What we have put in the presentation. I'll just give example of the book. Yeah, say it again.
Yeah, I think give a simpler example because it's only how many marks is it?
6 maybe. I'll check.
Yeah.
Doesn't matter
So
how many marks. I can't give this log to 2000. I'll learn better things than remembering these guys. Okay, carry on. So what's the example?
so if you have a book and you have the table of contents at the start of the book, so that's like the primary index. The book is ordered according to the chapters in the table of contents.
Yeah.
So if the primary index did not exist, that means
Which
if
is
the
the
table
table
of
of content did not
contents,
exist.
yeah, then
Okay.
you can still use binary search if you know the chapter number, because all the chapters in the book are in order. You don't have to search the book start from beginning. And if you want to search using a keyword, then all of the words in the book are not in order, so you will need an index if you want to search quickly. So you'll use the index that's normally there at the back of the book, and on the index you can use binary search because it's in order and you can find your keyword and then go to that page in the book. But if you didn't have that index, then you would have to search the book sequentially, and that would take a much longer time.
Okay.
So the difference between if a primary index doesn't exist and if a primary index exists is it's not that big. It doesn't improve the time that much, but the secondary index improves the searching time by a lot.
Okay, so if primary list does not exist, then you can perform binary search on the blocks of data records, as the records are ordered in sequence of primary index value. However, if the secondary does not exist, you may need to search the records sequentially if the records are not ordered by the secondary index value. Okay, fine, fine. I think we should be able to explain that. No problem. And to answer to your question, yeah, it's a 6 marks question. And we would have already scored at least 2 marks from this first one, or 3 marks, whatever that was there. Okay, so what is SQL? Explain create table command with the SQL with the help of an example. So SQL is a structured query language, and SQL is used to create and manipulate data. You can perform you can write queries, and you can request for the data. You can create a table, you can delete a table, you can alter a table, you can make mm, yeah, I think that's it so far. And then to create a table, you use the create table uh, command. So you write create table, and then the table name, and then inside of the round brackets you put the column name, the data type, the column width, and the after column width you have the constraint. So let's see. SQL. You'll get a lot of SQL, I guess. Okay, got it. Okay, so they're saying standard query language for accessing and manipulating databases. Is this simple? SQL is called non-procedural language as it just specifies what is to be done rather than how it is to be done. Since SQL is a higher level language, it is closer to the language like English, therefore it is user friendly. SQL can execute query against database, create new database, new tables, perform CRUD on database, create stored procedures, views in the database, set permissions on table, procedures, and views. Disadvantages of SQL are complex interface for users, cost for programmer, and partial user control. So, Kritika, go ahead and read these guys, and then we'll do a recap.
Yes, okay. SQL is a standard query language for accessing and manipulating databases. SQL is called a non-procedural language as it just specifies what is to be done rather than how it is to be done. Since SQL is a higher level query language, it is closer to a language like English. Therefore, it is very user-friendly. SQL can execute queries against a database, create new databases, new tables, perform CRUD on databases, create stored procedures, views in a database, set permissions on tables, procedures, and views. Disadvantages of SQL are a complex interface for users, cost for programmers, and partial user control.
Okay, so it's a structured query language for accessing, manipulating databases. It's called non-procedural language, and it just specified what to be done rather than how to do it. It's a higher query language, just like English, so it's easy to understand, user-friendly. You can execute queries, create tables and databases, perform CRUD, create stored procedures, views, set permissions. And disadvantage is the complex interface and cost for programmers. Is Sajjan there or Sajjan left? Hey Sajjan, how come you keep going out of the stream? Can you hear me, Sajjan? I don't know if he's there or not, but okay, no problem.
Actually, I'm using my phone, so I don't know why it's getting some touch problem. So I'm getting out again and again.
No problem. Let's read this again, Sajjan, and then we'll ask each other. So, can you read this?
Sure, I will read. So, what is SQL? It's SQL is a standard query language for accessing and manipulating databases. SQL is called non-procedural language as it is just specifies what is to be done rather than how it is to be done. Since SQL is a higher level query language, it is closer to language like English, therefore it is a very user friendly. SQL can execute queries against a database, create new database, new tables, perform CRUD on database, uh, create stored procedure view in a database, set permissions on tables, procedure, and views. Disadvantages of SQL are complex interface for user, cost for programmers, and partial user control.
Okay, so Kritika, give me 1 point on what is SQL.
It's a standard query language, and is used for accessing and manipulating data.
Okay, Sajjan, give me 1 point on this.
It's a user-friendly and higher level language
Uh, why is it user friendly?
because it is a higher level language. So its syntax is similar to English language. That's why it is
Very,
user-friendly.
very good. Okay, so Maya, give me 1 point on SQL.
It is a non-procedural language, which means that it specifies what is to be done rather than how it is done.
Yeah, correct. Kritika, do you remember any disadvantage of SQL?
A cost for programmers, a
Yeah,
complex
and it's
because of
complex for
complex interface.
non-procedural language just specify what to be done rather than how it is done. Cool. I think we know SQL. We'll go to the create table now. That must be the DDL. Yeah, data definition language, which is a set of commands to create and modify schema objects. Sajjan, can you read this?
Sure. DDL defines a set of commands used to create and modify schema objects such as table, index, views, etc. These commands provides the ability to create, alter, and drop these objects. Create. Explain create table command. Create is used to create a new table or a new database. Syntax create table, then square bracket, sorry, triangle bracket, table name, then column name 1 data type, column with constraint, then column name 2 data type, column with constraints. Example is this one. Yeah.
Okay. Kritika, tell me what does create table command do?
It creates a new table, creates a new table.
Can
Yes,
it create a database also?
yes,
Okay.
yes.
So may I give me the syntax for this?
Create table, then table name,
Yeah.
and then the list of attributes, column
Will there be
name,
a bracket first?
yes, brackets, and list of
Which one?
attributes in the
Which bracket?
round brackets.
Correct. Okay.
Then column name,
Yeah.
uh, data type, column
Yep.
width, and
Yep.
constraint.
Okay. Vidya, can you give me an example using this syntax, which Sumaya just explained?
Um, Create table customers,
Yeah.
and then column ID.
Mm-hmm.
I've learned it as student ID.
Yeah.
Okay, I'll create a table with student. Okay, create
That's
table.
fine. It's your baby, however you want to create it.
Okay, create table students. Um, uh, um, uh, so in the column name, we write student ID.
Yeah.
Uh, Student ID is type integer int.
Yeah.
Um, uh, Column with with
You
something
don't need
that.
column width for this. You don't need for this. For primary key, you don't need column width, but
Okay,
you need constraint. So what is constraint?
not null.
Yes. Yes.
Not
Give me
null.
one more field.
Um, Name,
Yeah.
variable character varchar,
Hmm.
column width 10, and
Will
a
it be in a bracket?
constraint brackets. Yes, round brackets.
Yeah. Okay. Constraint.
Constraints and not null.
Okay. Awesome. And I think at the end you have to put primary key like that, and then pass the ID. So the table knows that this is going to be the ID. So in your case, you'll say primary key and you put student ID in
Student
the
ID.
bracket. That's how the table will know that this is going to be a primary key. Okay, so you can see that ID does not have column width. Okay,
Okay.
moving on. Sajjan, could you please mute for some time? Thanks. Okay, looks like we're going good. We've done quite a few questions. We're moving on. We have to finish all these questions, so we'll go a little bit faster. So explain one-to-one relationship and many-to-many relationship in an ER diagram. So one-to-one in one-to-one relationship, uh, one entity on the left associates itself with another entity on the right in a relationship, forming a relationship. And in many to many, more than one entity on the left associates itself with more than one entity on the right with a relationship, and that's many to many. And when you create a diagram, so let me show you that. One, two, one. Yeah, here it is. So a relationship is used to describe relation association between entities one to one when only one instance of an entity associated with the relationship. That's when it's one to one, and it's denoted as 1:1. That's your diagrams. You have rectangle, let's say female, and then relationship name is married to, and then the second entity is male, and you put one and one over here to denote. That's your diagram, which the question is asking you to draw. Example, one female can marry only one male and one male can marry only one female. Then it's asking you many to many. So when more than one instance of an entity on the left and more than one instance of an entity on the right associates with the relationship, that's called many to many relationship. It's denoted by M:n. You put M on the left, N on the right. This guy is putting M, but ignore that. You put N here. Okay, N will always be put on the right and M will always be put on the left. So that's the rule. So see, N is always on the right. Okay, so N is also denoting many, but anytime it's on the right, you use N instead of M. And anytime it's on the left, when you deal with many, you put M instead. Okay, so example, an employee can be assigned many projects and a project can be assigned to many employees. So is assigned is a relationship, employee and projects are two different entities, and that's your diagram. So that answers your question for 4 marks. Okay, so we were on the D. We'll come here now. What is lossless join decomposition of relationship? Explain with the help of an example. I think lossless join is that when you join the table, then you don't lose onto any of the attributes. I believe you can form the same table as it was originally, something like that. So, Maya, do you remember this, or should we move on to the slides?
Yes,
Can you explain?
lossless join means that if you join the decomposed table, you should be able
Hmm.
to get back the original table that was decomposed.
Yeah, that's very simple way to explain, which is, of course, we decompose the table when there is redundancy, and that's normalization. So in normalization, we use any of the normal form to decompose the table into multiple tables. So let's say you have decomposed a table into two tables. If using the join operation, you know, if you're able to join those two tables and the result of which gives you the original table as it was in single piece, then that is lossless join. There's no loss that happened. Okay, so it'll ask you for an example. So let's see if we have an example. Lossless. So guarantees that join will result in exactly same relation as it was decomposed. I don't have an example. Maya, would you be able to put that create a new slide here and put that as an example?
Yes.
and mark that as a title. So I'll create a slide here, and I'll put like explain lossless join with example. So something sort of this might happen in exam. Like you might know the theory, but you might not know the examples. You'll have to probably make example at that point. So this is your lossless join. It's in your question paper. Send it to you. Yes. Okay, moving on. Explain three-level Dbms architecture with the help of a diagram. How does three-level architecture relate to data independence? Is put date independence. Explain with the help of an example. How many example are you guys gonna ask us? Don't you guys get tired? Every bloody thing you want an example.
Examples are like a cherry on a cake.
Yeah, and they won't give us good marks without a cherry. In fact, they don't still give you, no matter how beautiful your handwriting is and how dirty it is, in assignment they will not give you more than 70%. Some I hope they are not watching this recording because, because no matter what you do, whether you copy pasted, whether you have bought those pre-written, handwritten, all this, have you purchased it from any sale that was going on with discounts? It doesn't matter. I believe they don't even read it. Just give you 70 marks or 73, and they shuffle the marks so that you can't get to know that everybody's got the same marks. so, so the in form of an array, they have those marks 73, 74, 71, 70, and this is shuffle three.
Randomize 70 to
Right.
75.
Correct. So two students try to match it, they won't be able to. Okay, cool. So moving on. So three-level DBMS architecture basically is used for data abstraction for different types of users. There are three different types of levels. First is the physical or internal level, and then you have the conceptual or logical level, and then last one is the external or view level. And let's do the explanation. So the physical level is the first level in this architecture, and the physical level explains how the data should be stored, and the data is stored in form of bytes into hard disks. And it offers, finally I remember it, compression and encryption. And why I remember it is because last time when I didn't remember it, Sumaya like prompted me that that's the answer. That's why these group studies are helpful. Okay, and then we go to the conceptual or the logical level. So this is the second level after the first level, and this is basically determining the structure, the relationship between different entities, and the constraint applied on the database. And this doesn't care how the data is stored into the database. And there was one more point, I don't remember that. Then the last one is the user level, or the external level, or the view level. And this determines that every user will have different type of data showing to them, different view. Is not going to be shown all the data, so every user can have different data which is related to him. Yeah, I think that's that. Explain with the help of an example. So I don't know what example they mean. How does the three level, okay, data independence is talking about, right? Okay, yeah. So for data independence means that a change on one level doesn't make any difference on the other levels. And then you have the physical, two types of data independence. One is the physical data independence, and second is the conceptual data independence. So I'll just take you through the slides now. Must be the initial ones. Yep, and I would like somebody else to read now. Sajjan, you want to go?
Yeah, sure. Three-level database architecture. The three-level database architecture of the database was assigned by ANSI by data abstraction for different types of user. Three levels are physical or internal level, conceptual or logical level, external or view level. Physical level, this is the lowest level in the three-level architecture. It describes how data is actually stored in a database. In the lowest level, the data is stored in external hard drive in the form of bits, and the little high level, it can be said that the data is stored in file and folders. The physical level also discuss compression and encryption technique. Conceptual or logical level. The conceptual level is a higher level than the physical level. The purpose of the conceptual level is to define the structure, relationship, and constraint of the database system. It describes how the database appears to the user conceptually and relationship between the various data tables. It does not care for how the data in the database is actually stored. External level. This is the highest level in the three-level architecture and closer to user. If it only shows the relevant database content to the user in the form of views and hides the rest of the data. So different users can see the database as a different view as per the individual requirements.
Okay,
This is a different one. Uh,
go on.
okay, data independence and it's in the relation with the three-level Dbms architecture. Data independence means change of a data at one level should not affect another level. So we should not able to modify the schema at one level. Database system without altering the schema at the next higher level. The three-level architecture defines a single database system across all the three levels. Therefore, different level must map with each other. This mapping lead to the concept of data independence. There are two types of data independence. Physical data independence, it is defined as the capacity to change the internal schema without having to change the conceptual schema. If we do not if we do any changes in the storage size of the database system server, then the conceptual structure of the database will not be affected. It is used to separate conceptual level from the physical level. Physical data independence occurs at the logical interference level. Logical data independence. It defines characteristic of being able to change the conceptual schema without having to change the external schema. Logical data independence is used to separate the external level from the conceptual view. If we do any change in the conceptual view of data, then the user view of the data would not be affected. Logical data independence occurs at the user interface level.
Okay. So Maya, it's asking for example. What example do you think we can give?
I remember reading an example like between the conceptual level and the user level. Suppose you have a name column, and then at the conceptual level you decide to split it into two columns, first name and last name. Then the view level should not change. It should still have just the name column and display the name by joining the two columns, first name and last name.
Okay, can you add that here? An example.
Yes.
Example of data independence. यार इतना एग्जाम्पल मत मांगो यार. ये फिर एग्जाम्पल इट्स लाइक ये उठाते हैं यहाँ से विद द हेल्प ऑफ एग्जाम्पल और फिर दूसरा क्वेश्चन पेस्ट कर देते हैं वहां पे. एवरी स्टेटमेंट इज एंडिंग विद द हेल्प ऑफ एन एग्जाम्पल. Okay. So now we are on the second normal form and third normal form with the help of an example. So So Somaya, I'd like you to just explain, and then we'll go on to the slides. So let me recall what the first normal form. The first normal form was that each of the attribute need to have atomic value, which and the attributes should not be multi-valued, and none of the rows should be repeated. Correct? Say yes. Come on, say yes.
Yes.
Okay. Okay. Say now. Second normal form. So what's that?
A relation is in second normal form if it is in first normal form, and um, the non-prime attributes should be
Fully functional
fully
dependent.
functionally dependent on the key, on the primary key.
Okay, non-prime attributes should be fully functionally dependent on the primary key. Okay, and the third normal form.
The third attribute is in third normal form if it is in second normal form, and all non-prime attributes are directly dependent on the primary key. There should be no transitive dependencies.
Yeah. So let's go with that. Second normal form. So Sumaya, you have to drink some tonic to forget normalization, right? After the exam, I have to give you some tonic so you can forget about it.
I'm going to remember it all my life.
So मेरे को इतनी बार करवाया है ये normal form रट गया ये. You guys know Bruce Lee, right? You know what's the famous quote of Bruce Lee? That I'm not scared of someone who knows 1,000 tricks, right? I'm scared of person who has mastered one trick 1,000 times. So so it doesn't matter if we learn 50 different topics. If we can't retain them, if you can't remember them at the time of examination, is of no use. So it's important to revise. Cool. Yeah. So Maya, why don't you just go and read?
A relation is in second normal form if it fulfills the following criteria. It's in first normal form. All those attributes which are not part of any primary key are fully functionally dependent on the primary keys.
Okay.
Key features of 2NF: the partial dependency will exist only if the primary key is composite. Therefore, if the primary key of a relation consists of a single attribute, then the given 1NF relation would be in 2NF also.
I wouldn't even care about remember this guy. I'll just write this. It's just confusing.
This normal form decomposes a relation so that relations store information about one thing.
Okay, let's add one more thing here to make it easy. So that is non-prime attributes. So non-prime attributes are those attributes are not part of the primary key, are fully functionally dependent, fully and completely. Okay. Okay, go on with this example.
Okay, we have a teacher table with teacher ID, subject, and teacher age.
Yeah.
This table is in 1NF because each attribute has atomic values. However, it is not in 2NF because non-prime attribute teacher age is dependent on teacher ID alone, which is a proper subset of candidate key. So the
Yeah.
candidate key is teacher ID plus subject, and teacher age is only dependent on the teacher ID, not on the full candidate key. So it's
Okay.
not in second normal form.
Okay. Okay.
So to make it in second normal form, we have to split it into two tables, one with teacher ID and teacher age, and the second with teacher ID and subject.
Excellent. Just 1 second. Okay, why this is not animated? Just give me 1 second. So I have a standing desk. So I was tired of sitting. This automatic standing desk. Just push the button, goes on top. Okay, third normal form. Yes, go on.
A relation is in third normal form if it is in 2NF,
Mm-hmm.
and every non-key attribute of the relation is non-transitively dependent or directly dependent and can be directly derived from the primary key of the relation. In other words, a table is in 3NF if it is in 2NF, and for each functional dependency, at least one of the following conditions is true. X is a superkey of the table, or Y is a primary attribute of the table. It's a prime attribute of the table.
So every non-key attribute is directly dependent on the primary key. That's all I'll remember from that. Okay. So let me try to explain. So here, employee zip code, employee state, city, and district are directly dependent on zip code, but not directly dependent on employee code. That's why it's not in third normal form, correct?
Yes.
Okay. So that's why we break this table into two. And because these guys, all the group of Changu Mangu, all of those guys were dependent on zip, we put them in a group. Okay. So state, city, district, now they're directly dependent on zip, which is great, and that satisfies the condition of third normal form. And here we had the zip code and the employee name, which were directly dependent on employee ID. So now they are together, they all are happy. Okay. So I think we answered second normal form and third normal form with example, which is great. Moving on. What is data recovery? How can it be performed? Explain with the help of an example. Okay. So I'd like Kritika, you take over on this one. Data recovery. I don't think we have recapped this. So what are the questions? What is data recovery? How can it be performed? Explain the example. Okay. Okay.
What is data recovery? Data recovery is the process of restoring data that has been lost, accidentally deleted, corrupted, or made inaccessible. It ensures that the database is reliable and remains in a consistent state in case of a failure. Need for data recovery. When a system crashes, it may have several transactions being executed and various files opened for them to modify the data items. This crash could be because of software, virus, OS failure, hardware, disk fail, or external natural calamities failure. The aim of recovery scheme is to allow database operations to be resumed after a failure with the minimum loss of information and at an economically justifiable cost.
Okay, so let's mark some of the keywords. So data recovery is a process of restoring data that has been lost. That's the key thing. Okay. How it's lost could be accidentally deleted, corrupted, or made inaccessible. कभी कभी open ही नहीं होता है, inaccessible हो जाता है. It ensures that database is reliable and consistent. Remains in consistent state. Okay, what's the need? When system crashes, several transactions executed and various files open, modifies. The crash could be because of software failure, software, hardware, and external failures. Aim for recovery is to allow database operation. So what's the need? So this was like when it happened and why we need data recovery is because we want to allow the database operations to be resumed after a failure. After a failure, minimum loss of information and economic. Okay. So data recovery is basically process of restoring the data that has been lost, accidentally deleted or corrupted or made inaccessible. It ensures the database is reliable, remains in the consistent state in case of any failure. What's the need? Need is that when system crashes, it may have several transactions being executed and various files opened for them to modify the data items. This crash could be because of software, hardware, or external failure. Software could be virus, um, OS operating system failure, or hardware could be disk fail. External could be natural calamities such as earthquake or something. So the aim is that to restore them, basically allow the database operation to be resumed after the failure and with minimum loss of information. The loss of information should be minimum and economically justifiable cost. Okay, Sajan, you there? Sajan left. Okay, so Maya, can you read this? One second, let me just check if he's there. Oh, again, he's gone out of the stream. Sajan, are you there?
Yes, I am here.
Okay, can you read?
Sure. What is data recovery? Data recovery is a process of restoring data that has been lost, accidentally deleted, corrupted, or made inaccessible. It ensures that the database is reliable and remains in a consistent state in case of a failure. Need for data recovery. When a system crashes, it may have several transactions being executed and various files open for them to modify the data item. The crash could be because of the software virus OS failure, hardware disk fail, or external natural failure.
Okay.
The aim of the recovery scheme is to allow the database operation to be resumed after a failure with a minimum loss of information and at an economically justifiable cost.
Okay, so Maya, can you read this?
Yeah.
Maya?
Yeah. Data recovery is the process of restoring data that has been lost, accidentally deleted, corrupted, or made inaccessible. It ensures that the database is reliable and remains in consistent state in case of a failure.
Okay, so it's a process of restoring the data that has been lost, accidentally deleted, or corrupted, and it ensures the database is reliable and in consistent state in case of a failure. Okay, go on.
Need for data recovery. When a system crashes, it may have several transactions being executed and various files open for them to modify the data items. This crash could be because of software, virus, OS failure, hardware disk fail, or external natural calamities failure.
Okay.
The aim of the recovery scheme is to allow database operations to be resumed after a failure with the minimum loss of information and at an economically justifiable cost.
Okay. Kritika, give me one point about what is data recovery.
Data recovery is the process of recovering data in the case when in the case when there has been a natural calamity or system
Mhm.
failure or for some reason
Mhm.
we lost data.
Okay, that's fine. What is the need of, okay, so Maya, what is the need of recovering the data?
Um, to keep the database in a consistent state
Okay, okay,
in case there is a failure.
Okay, and the database operations can be resumed. You know, in which way? First is what is important related to the cost?
Cost should be minimum. The
Yes. Yes, it should be economical. Okay,
Yeah.
and what? Okay, Kritika, tell me like when we resume the operations, the database operations after a loss, then with relates to the information, what is important?
Minimum loss of information.
Correct. So one surgeon said economical should be not too expensive to regain that data, and second, Kritika said that the information should be a minimal loss, should not be much loss. And we established that data recovery is basically a process of recovering the data that has been lost. What is the reason? Could be the loss, could be data, could be failure, could be any type of failure like natural calamities, your software failure, like virus, your hard disk failures, that's a hardware failure. So these kind of things. I think we should be in a pretty good condition to uh, explain data recovery in the exam now, right? You all think so?
Yes.
Good. Next question was how it can be performed. We spent a little bit more time on this because we hadn't done this question, I guess, in terms of revision. So we spent more time on this one. So now we talk about how data is recovered and give example. Have you put example? Recovery is performed. Give example. Oh, this is example. I hate when this type of things come in. Okay, fine. We have to do it. So no escape. Following techniques can help database management system in recovering as well as maintaining atomicity of a transaction. Backward recovery, undo. The uncommitted changes made by a transaction to a database are undone. Okay, so if you're not committed anything, committed that part, you can undo it. Instead, the system is reset to the previous consistent state of a database that is free of any errors. Forward recovery, redo. In this scheme, the committed changes made by a transaction are reapplied to an earlier copy of the database, which means going back to the last commit. Log based recovery, maintaining the logs of each transaction and writing them onto some stable storage before actually modifying the database. Okay. Okay. So maintaining log, putting it on a persistent storage, and then modifying the database. So we have a backup of that log. Okay. Kritika, can you read this?
Yes. Following techniques can help data DBMS in recovering as well as maintaining the atomicity of a transaction.
Yep.
First, backward recovery or undo. The
Yeah.
uncommitted changes made by a transaction to a database can be undone.
Mm-hmm.
Instead, the system is reset to the previous consistent state of the database that is free from any errors.
Mm-hmm.
Second, forward recovery or redo. In this scheme, the committed changes made by the transaction are reapplied to an earlier copy of the database. Log based recovery, maintaining the logs of each transaction and writing them onto some stable storage before actually modifying the database.
Okay, let's go ahead and underline some of these key points. Following techniques in recovering, maintaining atomicity of transaction. Close this guy. Uncommitted changes made by a transaction to a database are undone. System reset to previous state. That is free from errors. Now, this is a condition. You have to go to a state that is free from errors. So uncommitted changes are undone. In this scheme, committed changes are reapplied. Committed changes reapplied to an earlier copy. Here, maintaining logs of each transaction, writing them onto stable storage. Stable storage before modifying. Harder to remember, but we'll try to make sense out of it.
Like very simply, from what I gather from this is backward recovery is what we do with Command Z, Control
Yeah,
Z.
yeah,
Forward recovery is Control Y, and log-based recovery is basically making a copy of it and then modifying it in the copy and like storing the previous one in a stable storage.
correct. So you made a story of it,
Hmm.
now you'll do command X, then command Y, and you'll maintain a log of that, right? You summarize
Yes.
in three statements. I hope you're able to explain it that well in exam.
Yeah, I hope so too. I hope so too. I think I miss out on a lot of keywords. Like even in another question,
Hmm.
like I could say everything, but I did not say the word schema. And I'm like, oh, I know what
So,
this is, but like I need specific
so, so,
words.
so let
Yeah.
me give you an example. Because the exam asks for examples. Let me give you a real world example. So,
Mm.
you know that movie in which Amir Khan was there? What was a comedy movie? Three Idiots, right?
Yeah. Yes.
What was his name in that? Uh,
Rancho.
Rancho, right? So you are Rancho basically, who explains things in simple manner. And Sumaya is actually Chatur, who goes by word. The examiner is going to be very happy looking at her answer when she was giving the three normal form and she started giving answer of without even looking. I was like, now you started your jargon, all those all those keywords. लेकिन एग्जाम में पास होना है तो सुमैया को बोले नहीं तुम यही लिखोगे जो सुमैया बोल रही है
I
कंट्रोल एक्स
actually
करके
don't
बोले
remember so much.
हाँ
I actually don't remember so much, really specific things.
yes yes
And who
so
are you from Three Idiots?
me I'm I'm Dr. Virus. Uh,
Yes, that
okay.
sounds right.
That sounds right, right?
Yes, professor and everything. Yeah.
As
Um,
expected.
no, but I think I'm very thankful to Sumaya also because both of you, so
Yeah.
Imran and Sumaya, like if I'm gonna pass in this exam, it's because of like you two, you know.
Yeah, you're gonna
Like
pass an exam if these stupid guys put these questions in the question paper. Otherwise, you're just gonna blame. Okay. Well, hopefully that
yes.
happens this time.
Yeah, no, I
Cool.
mean, I
So
think most of it is covered in the PPT, right? So
yeah, yeah.
it should be okay.
We have other stuff to do, right? Besides just learning this, we have our work, we have our household chores, just too many things. Like
Yes.
I was traveling the entire day today. So I work. I finished my work, then I was traveling for about 6 to 8 hours. From Mumbai to Pune. So there was a lot of traffic. So I was like really tired. But I thought, let's do it because we need to get good scores. Okay. So
Mm.
coming back. So backward recovery is uncommitted changes made by the transactions are undone. Forward recovery is committed changes are reapplied. If you have to remember in one sentence, is like uncommitted changes are undone, committed changes are reapplied, and in log-based recovery, maintaining the log of each transaction, writing them onto stable storage before modifying it. Okay, Sumaya, can you read this?
Following techniques can help a DBMS in recovering as well as maintaining the atomicity of a transaction. A backward recovery undo the uncommitted changes made by a transaction to a database are undone. Instead, the system is reset to the previous consistent state of the database that is free from any errors. Forward recovery or redo in this scheme, the committed changes made by a transaction are reapplied to an earlier copy of the database.
Okay.
Log-based recovery, maintaining the logs of each transaction and writing them onto some stable storage before actually modifying the database.
Okay, so techniques are, I'll start from the bottom. So basically maintaining logs. So we maintain the logs before we actually start applying our changes. And we maintain the log into some persistent storage like a hard disk. So Maya, give me one of the points for how the data recovery is performed.
Backward recovery, undo.
Yeah,
So
how's that
that
done?
is performed on uncommitted changes from the transaction.
Hmm.
The database is restored to its previous consistent state.
Okay, so uncommitted changes are undone, right?
Yeah.
System is reset to previous state, and that is free from errors. Okay, okay. Kritika, give me the last point.
The second point, forward recovery
Hmm.
or redo. Redo it. The committed changes are applied to the previous copy.
Yeah, it's just the reverse of this. The committed changes are undone. Sorry, uncommitted changes are undone, and their committed changes
Committed
are
changes are
reapplied.
reapplied
See,
to the
just the
previous
exact
database.
reverse of that. Uncommitted, undone, committed,
Mhm.
reapplied. Okay, and then I'm sure we guys are pretty smart to just elaborate on that.
Mhm.
Okay, so this is an example. Example, the log keeps track of all the transaction operations that affect the values of the database item. So we've explained that these are the three different types of data recovery uh, options. Now we'll give example, but we'll give example with the log-based recovery because probably that's a simple one. So the log keeps track of all the transaction operations that affect the values of the database items. This operation is needed to recover from the transaction failure. So transaction is initiated, writes start log. So log one is transaction is initiated and writes start log. Okay. Then T start transaction modifies the address from Pune to Mumbai. Address T address Pune Mumbai. Then log three is transaction is completed. Log indicates the end of the transaction. Then we log commit. And that's it, I guess. So log one is transaction is initiated, write start log, then log t start. Log two is transaction modifies the address from Pune to Mumbai. Then log t address is making note of the address, whatever was changed. Log three transaction is completed. Log indicates the end of the transaction. Log t commit. Commit is saving. Assume at this point of time a failure occurs. Since the transaction has committed, we have performed redo for recovery. So at this point, because we maintain logs and we had committed, at this stage we kind of saved it. We've saved whatever was done, so we could redo this for recovery. So redo was which one? This one. Committed changes are reapplied. So let's say you do this, which is update the address, and then you commit it, which is saved, and then you make an error. You do something else and you make an error. You don't want anything after this commit. So that's why this whatever this commit was, you reapply that using the log. So that's what it is. So Maya, can you just quickly explain this part quickly?
The log keeps track of all transaction operations that affect the values of database items. This information is needed to recover from transaction failure. A log
Mhm.
one transaction is initiated, write start log. Log t start transaction modifies the address from Pune to Mumbai. Then you log t address Pune Mumbai. Transaction is completed. The log indicates the end of the transaction. And then t commit. Assume at this point of time a failure occurs. Since the transaction has committed, we have to perform redo for recovery.
Okay. Moving on. How many more questions? One. We won't do this today. We will do this tomorrow. But yeah, we'll do the others. So not much left. We have these guys, and we have one question here. Query optimization in context of database management system with the help of an example. Query optimization. Give me 1 minute. Okay, I want somebody to read this. Kritika?
Yes. Query optimization with examples. The query optimizer uses these two techniques to determine which process or expression to consider for evaluating the query. Cost-based optimization of physical. This is based on the cost of the query. The query can use different paths based on indexes, constraints, sorting methods, etc. This method mainly uses the statistics like record size, number of records per block, number of blocks, table size, whether whole table fits in a block, organization of tables, uniqueness of column values, size of columns, etc. Heuristic optimization or logical. This method is also known as rule-based optimization. This is based on the equivalence rule on relational expressions. Hence, the number of combination of queries gets reduced here. Hence, the cost of the query reduces. This method creates relational tree for the given query based on the equivalence rules. The most important set of rules followed in this method is listed below. Perform all the selection operation as early as possible in the query. This should be the first and foremost set of actions on the table in the query. By performing the selection operation, we can reduce the number of records involved in the query rather than using the whole tables throughout the query.
Okay. I think it's too big. We have to break it down. Just 1 second. We have to break it down probably in 2 slides. And the second slide will be heuristic. First one, we just do cost-based optimization. Okay. So this is based on the cost of the query. Okay, so based on cost. So this is a keyword in this. Query can use different paths based on indices, constraints, sorting methods. So query can use different paths. This method mainly uses statistics like record size, number of records. So May, have you done this question? Like, have you read about it?
Yes.
Does this answer look appropriate to you?
Yes, I think it's good.
Okay. So uses statistics like record size, number of records per block. Now we're going to be smart. We're just going to chuck these guys off. It's too much. Our mind cannot remember that much information. So mainly uses, you probably break that like that. statistic like record size, number of records per block, uniqueness of column values, size of columns, etc. That's it. Okay, so it looks that was like too much. Okay, coming back here. This method is also known as rule-based optimization. Why do I want to have a whole statement for that? Unnecessary. Just put that here. Rule-based optimization. So this is based on equivalence rule. Based on equivalence rule on relational expression. Hence, the number of combination of query reduces here. Hence, cost of query also reduces. This method creates relational tree. For given query based on equivalence rules. Most important set of rules followed in this method are perform all selection operation as early as possible in the query. Perform all selection operation as early as possible. This should be the first and foremost set of actions in the tables of the query. By performing selection operation, we can reduce number of records. Okay, so let's review it, see if we understand this. So query optimizer uses two techniques to determine which processor expressions consider for evaluating the query. Two techniques determine which process or expression to consider for evaluating the query. Cost-based optimization. This is based on the cost of the query. The query can use different paths based on indices, constraints, sorting methods, etc. So to optimize, these are the paths it's going to use: sorting, indexing, constraint. This method mainly uses statistics like record size, number of records per block, uniqueness of the column values, size of the column, etc. So that's your cost. So cost is mainly to do with the cost of the query. For optimization is going to use different indexes, constraints, sorting methods. Now this method is going to use some stats. So what will be the statistics? So it's going to check what is the size of the record, what are the number of records, what's the number of records per block, the uniqueness of the column values, size of the column. So it's going to look at that stats, and based on that is going to do its optimization and see which is more expensive, basically. So it's basically to do with the cost, the expensiveness of the query. Then this is heuristic optimization, which is rule based. It's going to follow some rules. Rule based. Okay. So this is based on equivalence rule on relational expression. Hence, the number of queries gets reduced here. What is the meaning of heuristic? Is it logical? Heuristic approach, I've heard that statement. Enabling someone to discover or learn something for themselves. Heuristic, a hands-on, interactive heuristic approach to learning. Enable someone to discover or learn something for themselves. What is heuristic? Mental shortcuts that allow people to solve problems and make judgments quickly and efficiently. Like what? Reduce mental effort, simply complex, difficult. They are fast, accurate. Okay, so yeah, mental shortcuts that allow people to solve problems. That's heuristic. So logical, this is based on the equivalence rule on relational expression. Number of combination of queries gets reduced. Cost of the query also reduced. This method creates a relational tree for the given query based on the equivalence rules. Most important rules are follows. Perform all selection operation as early as possible. This should be first and foremost set of actions on tables in the query. By performing the selection operation, we can reduce the number of records involved in the query rather than using the whole tables throughout the query. Yeah, so here they're talking about, for example, I don't know if you remember when we were doing the statement writing on the SQL bolt, instead of writing select all, where it's going to, you know, select all the records and display everything, we may not need all of that. All we want is just maybe title and name, title and let's say date of birth. So that's all I'll write instead of putting all. So that's optimization. By performing selection operation, we can reduce the number of records involved in the query. We don't want everything. We don't need to use the star rather than using the whole table throughout the query. So that's optimization. Performing all selection operation as early as possible in the query. Okay, this should be the first and foremost set of actions. Method creates a relational tree for the given query based on equivalence rules. Based on equivalence rule. Fine. Let's revise this. Sumaya, do you want to go? And Sumaya, if you have any other points which you can talk about in query optimization, go ahead. Okay.
Okay. The query optimizer uses these two techniques to determine which process or expression to consider for evaluating the query. Cost-based optimization, physical. This is based on the cost of the query. The cost of the query is basically the time taken to execute the query. The query can use different paths based on indexes, constraints, sorting methods, etc.
Let me write that down. Let me put that in the bracket because this is not like a answer, it's just for our reference. Or maybe we can still write this point. There's no harm in that. Go on.
The query can use different paths based on indexes, constraints, sorting methods, etc. This method mainly uses the statistics like record size, number of records per block, uniqueness of column values, size of columns, etc. Heuristic optimization, a logical rule-based optimization. This is based on the equivalence rule on relational expressions. Hence, the number of combination of queries gets reduced here. Hence, the cost of the query too reduces. This method creates relational tree for the given query based on the equivalence rules. The most important set of rules followed are: perform all the selection operations as early as possible in the query. This should be the first and foremost set of actions on the tables in the query. By performing the selection operation, we can reduce the number of records involved in the query rather than using the whole tables throughout the query.
Okay, so just a recap to tell you, basically the heuristic is really easy. Cost based, I think, is also easy. Cost based optimization relates to the cost of the query, like how much time it takes. So the time, so smaller the time a query takes to execute, uh, faster the execution, better the performance. Okay, so how to ensure that the time it takes is less? So you can use different paths like indices, constraints, sorting methods. You can sort it properly, and then how efficient your query is basically. So you can check the stats like the what is the size of the record, whether it'll be efficient to get that big of record, or to get only small part of the record, number of records that you're getting. Let's say on a database you want only one item, but you are getting everything. Doesn't make sense. So when you're writing a program, sometimes you will get the data in form of an array, and your requirement is only to get one data, so you'll probably just use limit one. So if you use limit one, you're only going to get one data. So number of records matters in the cost of the query, because if you're going to get 100 records, then it's going to take more time versus if you get just one record. So that's what it talks about, and looking at the statistics you can decide what you need to do, how to improvise the query. The number of records per block, uniqueness of column values, size of the columns, etc. Then this one talks about different rules that you can apply. So it's based on the equivalence rules of relational expression. So here, hence the number of combination of queries gets reduced here, and the cost of the query reduces also. It creates a relational tree for given based query based equivalence rules. So key thing here is that when you are writing a query like select, title, whatever, selection should be done as early as possible. Okay, not towards the end. And that's what it's saying in the second line also. There should be first and foremost set of action on tables in a query. And by performing selection operation, an efficient selection operation, you can reduce the number of records. Rather than getting all, you just get the ones you want. So yeah, I think we should be able to describe that in the exam. I know it's almost 2 hours. If some of you want to leave or go, it's completely fine. But I'll finish the rest of these questions. I won't spend too much time on these guys, but at least we'll read it a couple times so that we get familiar. So we have data mining, data warehousing, NoSQL database, locking, and weak entity. This is easy. I mean, I can just say it. Weak entity is basically an entity in a relationship which is dependent on another entity. It is represented by a double rectangle. For example, there is two entities. One is student and second is guardian. So guardian is your weak entity. It is dependent on student, and the weak entity does not have its primary key on its own, but the strong entity does. So you can talk about that. And yeah, locking in the transaction. Yeah, I'll come to that. Let's go to the data mining first. Irrespective whether we complete or not, we'll stop at 12. Data mining, because tomorrow's day will maybe mainly for finishing all the problem related work. So data warehousing versus data mining. Is there a difference? Okay. I think if we read this, we'll be able to cover both of them together, couldn't we? And then we'll be able to distinguish also. So I think it's better to do this one instead of doing them separately. Let me pull this guy. I'd like somebody to read. Maybe Sachin, you want to read? If you're still there.
Yeah.
Okay, cool.
So there is a difference between data warehousing and data mining.
Yep.
Definition. Data warehouse is a database system that is designed for analytical analysis instead of transaction work. Data mining is a process of analyzing data pattern. Data is
Okay.
stored periodically. Data is
So
analyzed
explain the first
regularly.
part in simple words. Explain the first part. What is looking at it? What do you derive from that? What is data warehousing?
It is okay. First of all, data mining में data is analyzed in a data pattern और इसमें
Okay.
कोई specified data pattern is an analytical analysis transactional work के लिए use होता है.
Mm-hmm. So it's designed for analytical analysis.
Yeah,
Okay, so it's a database
instead of
system.
transational work.
Okay, so data warehouse is
Yeah.
like a place where they have a database system, and what is that used for? It is used for analysis instead of transaction. So we have a normal database which we use to perform queries for users, but sometimes we want to analyze users' data. So we have a data, we take a copy of it, we store it somewhere, and then we analyze. Okay, so how many users came? What is the number of users we have? What are the number of sales? Which products have got higher sales? So, all these analysis that a business does, that all analysis is done on a database, and that database is called a warehouse, database warehouse. But the key thing you need to remember is that it is not used for transactional work, which is, it is not being used on his application, on his software. It is just kept separate, and all the main purpose of the database, to keep that database, is to be able to analyze what's happening for business improvement. Okay, data mining is the process of analyzing the data pattern. Okay, so we have a warehouse, and you can do the analysis through data mining on that warehouse. So data mining is usually done on the warehouse. You need to have a database system to be able to analyze those things. So the process is called data mining, and the data itself, which is used for analysis, is called data warehouse. You guys are clear on this?
Yeah, got it.
Okay, go on.
Yeah, data is stored periodically. Data is analyzed regularly.
Okay,
Data warehouse is the process of extracting and storing data to allow easier reporting. Data
okay,
mining is used to pattern recognize logic to identify patterns.
okay,
Yeah, data warehouse is solely carried out by engineers. Data
okay,
mining is carried out by the business user with the help of engineers.
okay.
Subject-oriented, integrated, time-varying, and non-volatile constitutes data warehouse. AI,
Mm-hmm.
statistics, database, and machine learning system are all used in data mining technology.
Mm-hmm.
Okay, data warehousing is a process of extracting and storing data in order to make reporting more efficient.
Mm-hmm.
And pattern recognition logic is used in data mining to find pattern.
Mm-hmm.
Users, it extracts data and stores it in a orderly format, making reporting easier and faster. The
Mm-hmm.
procedure employs pattern recognition tools to aid in identification of access pattern.
Okay.
Examples are there. When a data warehouse is connected with an operational business system like CRM system, it adds value. Data mining
Mm-hmm.
adds the creation of a suggestive pattern of the key pattern, the customer purchasing behavior, item sales examples. As a result, business will be able to make the required adjustment to their operation production.
Excellent.
Yeah,
Kritika, you want to go over it once again?
Yes, okay. Data warehousing and data mining. Data warehouse is a database system that is designed for analytical analysis instead of transactional work. Data mining is the process of analyzing data patterns. Data is stored periodically, data is analyzed regularly. Data warehousing is the process of extracting and storing data to allow easier reporting. Data mining is the use of pattern recognition logic to identify patterns. Managing authorities, data warehousing is solely carried out by engineers. Data mining is carried out by business users with the help of engineers. Data handling, data warehousing is the process of pooling all relevant data together. Data mining is considered as a process of extracting data from large data sets. Functionality, subject oriented, integrated, time varying, and non volatile constitute data warehouses. There are data, AI, statistics, databases, and machine learning systems are all used in data mining technologies.
Okay.
Task, data warehousing is the process of extracting and storing data in order to make reporting more efficient.
Hmm.
Pattern recognition logic is used in data mining to find patterns.
Okay.
Uses, it extracts data and stores it in an orderly format, making reporting easier and faster. This procedure employs pattern recognition tools to aid in the identification of access patterns.
Hmm.
Examples, or when a data warehouse is connected with operational business systems like CRM systems, it adds value. Data
Yeah.
mining aids in the creation of suggestive patterns of key parameters. Customer purchasing behavior, items, and sales are examples. As a result, businesses will be able to make the required adjustments to their operations and production.
I think I'm pretty sure, pretty confident that we'll be able to write about data warehousing and data mining, explain in our own words. But it'll be useful if Kritika, you can create a story out of it tomorrow and share it with us.
Yes, okay, I'll try to do that.
Okay.
Okay.
I think we need an example or something. Are they asking for no, no, just short notes, so it's fine. So yeah, we don't really have to go through this slide because we've already gone through that. It's fine. So we've killed two birds with one stone. So we've done with these two. We're done with this guy. We'll do this one now. NoSQL databases, which is I think it's not very difficult. It's pretty easy. NoSQL. Imagine I wrote 200 and what 13 slides. Like tired. Okay.
And the same number for Java as well.
Let's see. They might ask you the difference between these two. Um, so yeah, I guess let's just first read so what a NoSQL database, and then we'll see the difference. Okay, so Maya,
Yeah.
imagine if
NoSQL.
we were 1 second. Imagine we were kids, like we were very young in schools. At this point of time, our parents will be really happy that our children are studying at such late night. That's really good. But I'm pretty sure now our parents might not care that much as they'll care if we were young and not studying. Yeah, go on.
NoSQL, non-SQL or non-relational is a database that provides a mechanism for storage and retrieval of data in means other than the tabular relations used in relational databases.
Yeah. So, in simple words, no SQL means that no structured query language, and uh, it's a database. So the first thing you will remember is to write about what is a database. It provides a mechanism for storing and retrieving the data. Okay, uh, and it's that type of database. Okay, it's a database where you can store information and you can get information, input and output. Okay, so but what type? So type is where there is no tabular relationship, which is used in the relational database. So it is not relational database, which means you are not going to get tables here in the NoSQL. Yeah, let's go on.
In a NoSQL database, a book record, for example, is usually stored as a JSON document. For each book, the item, ISBN, book title, edition number, author name, and author ID are stored as attributes in a single document. In this model, data is optimized for intuitive development and horizontal scalability.
Yeah, I have used one of them. I think I've used MongoDB, where data is stored in form of JSON format, and it's pretty useful actually. So I'll show you an example in a moment.
Types of NoSQL database. Key value Key value databases are highly partitionable and allow horizontal scaling at scales that other types of database cannot achieve. Document in application code, data is represented often as an object or JSON-like document because it is an efficient and intuitive data model for developers.
Yes, and it will be really useful in object-oriented programming because you already have that in a JSON format, key value pair.
Graph database's purpose is to make it easy to build and run applications that work with highly connected datasets.
Okay, so now you're talking about different types of the NoSQL databases. You have key value pairs, you have the document types, you have the graph type.
In memory, gaming, and ad tech applications have use cases such as leaderboards, session stores, and real time analytics.
Okay.
Advantages of NoSQL databases: flexibility. NoSQL databases generally provide flexible schemas that enable faster and more iterative development. The flexible data model makes NoSQL databases ideal for semi structured and unstructured data. Scalability: NoSQL databases are generally designed to scale out by using distributed clusters of hardware instead of scaling up by adding expensive and robust servers. Some cloud providers handle these operations behind the scenes as a fully managed service.
Mm-hmm.
High performance NoSQL database are optimized for specific data models and access patterns that enable higher performance than trying to accomplish similar functionality with relational databases. Highly functional NoSQL databases provide highly functional APIs and data types that are purpose built for each of their respective data models.
So, when you are using the relational database management system, there the data may not be in a shape that you really require, and you have to modify it. You have to create a function, put it in a shape that you required. But if you're using in form of JSON, in form of objects, then it's already in the format that you need it, and then just makes it a life a lot easier. So let me just show you. Um, no SQL database JSON example. Let me see. Yeah, look at this. How simple it is. Customer, you have ID, first name, last name, key value pairs. Then you in the address, you may probably create another table for address and everything, but here it's all in like parent-child relationship. There could be another one, city, and then uh, and another key value pair object, and keep going deep and deep. This can be in form of an array. You have phone numbers, type, number. Yeah, just so simple. Basically, that's your NoSQL. What's left? Locking. Last one out. We haven't spent too much time because time crunch. What tomorrow after we do all our practice like writing queries and ER diagrams, all of those things, and normalization, then we can come back and we can start from the bottom and pick up the ones where we are not very confident that we have spent too much time, enough time. So let's do. But the reason I'm doing it today, because if we do it today and we do it again tomorrow, then the chances of you retaining that information is more compared to if you just read it once. Okay, locking. So I'll explain to you locking in a simple word, and then we'll look at that. So what happens is that we read about the problem of the concurrent transaction, right? Like we understood what a transaction is. It's a single unit of work for database transaction. We read about that there could be scenarios where two transactions are trying to update the same record. That's called concurrent transaction. We discussed there are problems like lost updates loss, as well as you have issues like analysis updates problem. So quite a few problems that we get when two transactions are trying to update the same data. So to solve that, the locking is used. So what happens in locking is that, let's say a transaction wants to edit a data. What it's going to do is it's going to go to a manager. I think, what is that called? Transaction manager, lock transaction manager, something like that. We will look at what is the exact name is. We'll go to that manager. It will say that I want to go ahead and modify this data. So I need a lock for this. I need to put a lock on this particular data item. So transaction manager is going to check if there are no other transactions that are already modifying that. There's no other lock place. So it's going to pass that request, fulfill that request. So that transaction is going to start working on that, maybe reading, writing, whatever it wants to do. And once it finishes that, then it's going to release that lock. while it's performing the operation, while it's in the lock phase, if somebody else comes in and requests the transaction manager that give me lock for this one, I want to modify it, it won't allow unless and until the transaction that is actually modifying it voluntarily releases the lock after finishing its work. So that's how locking is really useful, because that means no two transaction can modify or work on a particular data item, the same data item at the same time. So that's basically a locking is. So like Sajjan, you want to read?
I'll just join back in 2 minutes. Okay, I'm gonna go to my cabin. I'll join back.
Yeah, yeah, no problem.
Yes. Okay.
Let me see if Sajjan is still there.
Yeah, I'm here.
Sajjan, okay, let's read it.
Locking. Locking is a technique used to lock some data in database so that only one database user session may update that particular data. This
Mm-hmm.
prevents two or more database users from updating the same exact place of data at the same exact time.
Yeah.
A lock can be placed by transaction on a shared resources that it desires to use. When this
Okay.
is done, the data is available for the exclusive use of that transaction. That is, other transactions are logged out of that data item.
Okay.
When transaction that has logged a data item does not desire to use it anymore, it should unlock the data item so that other transaction can use it. If transaction tries to lock a data item already logged by the some other transaction, it cannot do so and wait for the data item to be unlocked.
Correct.
So, all lock requests are made to concurrency control manager. Transaction placed only once the lock request is granted. Example: assume that two people who go to electronic kiosk at the same time to buy the movie ticket for the same movie and the same show time. However, there is only one seat left in the movie show in the particular theater. Without concurrency control and Dbms, it is possible that both the moviegoers end up with purchasing a ticket. However, concurrency control method does not allow this to happen. Both moviegoers can still access information written in the movie ticket database, but currency control only provides a ticket to buyer who has completed the transaction process first. Yeah,
Okay. So Sajjan, let me wake you up.
yeah.
So let's say you go to washroom and you don't put a lock. What will happen if somebody else comes in?
You will not
So
be able
same
to
thing,
enter.
same thing here. So if you're going to washroom, then you have to put a lock. So and when you're done, you come out and then somebody else will go. Okay, so that's locking basically. Okay, how locking solves concurrent transaction problem? I think we already done this, haven't we? No, we haven't, right? Yeah. Okay, so Maya, let's read this and then we'll call it a night.
Okay. Lock-based protocols in DBMS is a mechanism in which a transaction cannot read or write the data until it acquires an appropriate lock.
Mm-hmm.
Lock-based protocols help to eliminate the concurrency problem in DBMS for simultaneous transactions by locking or isolating a particular transaction to a single user. Types of locks are binary lock and multiple mode locks. Binary lock. This locking mechanism has two states for a data item locked and or unlocked. In the given example, when you obtain all the locks at the beginning of the transaction and release them at the end, it ensures that transactions are executed with no concurrency related problems.
Okay.
Multiple mode locks offers two locks, shared lock or read only lock. With the shared lock, the data item can be shared between transactions. This is because you will never have a permission to update data on the data item. For example, consider a case where two transactions are reading the account balance of a person. The database will let them read by placing a shared lock. However, if another transaction wants to update that account's balance, Shared lock prevents it until the reading process is over. Exclusive lock. With the exclusive lock, a data item can be read as well as written. This is exclusive and can't be held concurrently on the same data item. Xlock is requested using lockx instruction. Transactions may unlock the data item after finishing the write operation. For example, when a transaction needs to update the account balance of a person, you can allow this transaction by placing Xlock on it. Therefore, when the second transaction wants to read or write, exclusive lock will prevent this operation.
Okay, so just to recap on this one, so basically there are two types of locks, binary and multiple. Binary locks has two locks, lock and unlock states actually. When you are, so in this, the rule is that you're supposed to obtain the lock on all the data items that you want to perform at the beginning of the transaction. So let's say you want to perform some transaction on X and Y, you have to put a lock in the beginning itself. You can't put a lock on X, then work on it, then all of a sudden you want to work on Y, then you apply the lock. You have to acquire all the locks in the beginning on the items you want to modify. So here we are applying those locks and then working on it. In between, if somebody else comes in, some other transaction comes in, say that I want to modify these guys, you can't do that because until unless these guys are released. And when will you release it? You release it after you've performed the entire operation. Even though you are finished with one of them, working on one of them, you're not going to release it. You're going to release it only when you're finished working on all of the data items that you had acquired lock for. So multiple mode lock, you have shared lock. Shared lock is usually used for simple things like reading. If I want to read a data, I don't have to worry, because if you just going to read it, whether one person reads it or 10 people read it, doesn't really matter, because it's not going to change, because you're not making any change. The shared lock can be acquired by multiple people. So multiple transactions can acquire the shared lock on the same item. So T1 can acquire, T2 can acquire, T11 can acquire the shared lock on that. But the rule is that you can read it, you can't modify it. Exclusive lock, when you apply that, that means you can read it, you can also make changes. But if you take this lock, which is denoted by X, then you nobody else can work on this particular data item if you have acquired that exclusive lock. Cool. So I think that's about it for today. So tomorrow we meet at Sajjan, what time you're free tomorrow?
Tomorrow,
Yeah.
same time as today.
Okay. What about you, Kritika? Are you also available same time, 9:30?
I am free, but I'm not fully sure if I'll be able to join. But I'm free at 9:30. I'll join most likely.
Okay, because the tomorrow is going to be important, because we'll be doing all the solutions of the problems like ER diagrams and queries and all of those things. There'll be less of theory and more of doing practicals, because if you're doing practicals, then you most probably remember on Saturday in the exam. So even if you're able to join for some time, let's say half an hour, 1 hour, it's okay. But if more the participation, the better it is. So 9:30 sounds good for you, Kritika?
Yes, okay.
Okay. What about you, Sumaya? Are you comfortable with 9:30?
Yes.
Okay. Sajjan, you're fine with 9:30, right?
Yes, I'm comfortable.
Okay. So let's do a 9:31. It'll probably go up until 9:30 to 11. We want to feel fresh the next day, so I don't want to extend it till 12. So we'll aim to finish all the problems first, the practical ones, and then we'll go on to revising from backwards, and only the questions where we are not really confident that we can even write a few sentences, we'll do them first. Okay,
Okay.
cool
Yes.
then. Thanks, guys. Thank you for participation. It was pretty long, and you have a good night. I hope you session was fruitful.
Yes, it was.
Cool, cool.
And
Take care then. Bye bye.
take care.
Good
Bye
night.
bye. Good night.
Good night.